So today's note's going to be a little bit different. We're going to be looking at how to draw Bohr-Rutherford diagrams. But for this part of your notes, you actually don't have to write anything down. If you would like to add to your notes that already exist, you are more than welcome to do that. But what I would recommend you do is actually just listen to the rules on drawing these Bohr-Rutherford diagrams and then trying some on your own to make sure that you're getting it right. So, your learning goal. You need to be able to draw a Bohr-Rutherford diagram with the correct number of protons, neutrons, and electrons for the first 20 elements on the periodic table. So by the end of this video, you should be able to do that. So here are your rules. And again, these are already written. Let me move that out of the way. These are already written in your notes, so you don't need to recopy these. So first rule, or the first step, a circle is drawn in the center, and that represents the nucleus. Then we write the number of protons and neutrons inside that circle, because we know that the protons and neutrons exist inside the nucleus, whereas the electrons are hovering outside and around the nucleus. So we draw a circle and we write the protons and neutrons in the circle. Then we have to draw the electrons. So the electrons are actually shown in orbits. We have 2 electrons in the first shell, or the first circle, 8 electrons in the second shell, 8 electrons in the third shell. After that, it gets complicated, and you don't actually learn that till grade 10 and 11, so we're not going to worry about that. We call this the 288 rule, okay, because it works to tell us how many electrons go in each shell for the first 18 elements. So let's do one together. So I'm going to basically, we're going to look at chlorine. Oh, here, you know what? I'll just take this off. We'll just draw it in. So you already have the Bohr-Rutherford diagram of chlorine in your notes. So I'd like you to just follow along and watch how I got that diagram. So if we look at your standard atomic notation for chlorine, it looks like this: 36, Cl, and 17. So the first thing you have to do, you have to be able to write the protons, neutrons, and electrons in your Bohr-Rutherford diagram. So we've got to look at chlorine and figure out how many protons there are, how many neutrons there are, and how many electrons there are. Once we have that information, then we can draw in our Bohr-Rutherford diagram. So let's do that now. I'm going to write that in red. So the number of protons, I'll just put P for protons, is the same as the atomic number. My number of electrons is the same as the number of protons, because remember, they have to be equal. They're always equal. My number of neutrons is sort of the trickier one to find. Remember what we do? We take the mass number and we subtract the atomic number. So we have to do 36 minus 17. That gives us 19 neutrons. All right, so now I know how many of each we're going to draw. So now we can actually start by drawing the Bohr-Rutherford diagram. So I'm going to do the Bohr-Rutherford diagram in black and green, just again to color code it for you guys. So step 1, right here, says a circle is drawn in the center to represent the nucleus. Just going to scroll this down a little bit. So here's my circle in the center. Step 2 says the number of protons and neutrons are written inside the circle. Well, how many protons do I have? I have 17, so I write 17P for protons, and I write neutrons, 19N for neutrons. Okay, you always have to write P and N to indicate which one's the protons and which one's the neutrons, and you get a mark for each one of those. Now we have to draw in our electrons, and we have 17 of those to draw in, so I'm going to draw those in green. Okay, so the first 2 electrons are in the first shell. So we actually don't have, so it's kind of like planets orbiting the sun. So here's the first shell, and you've basically got 2 electrons, one up top and one on bottom in that first shell. The second shell is going to be a little bit bigger. Okay, and I'm going to have 8 electrons in that shell. So I start by going up at the top, down to each side. That's 4. I'm going to pair them up. 5, 6, 7, and 8. I can only draw 8 electrons in the second shell. So now my second shell is full. So the rest of the electrons have to go in. So now I've drawn 10 electrons, right? 2 in the first shell and 8 in the second shell. So I still have 7 more to draw. So where are they going to go? They're going to go in the third shell. So I have to draw another shell a little bit bigger. and I'm going to put 7 electrons. So again, in order, 1 at the top, 2 at the bottom, then the 2 sides, that's 3 and 4. Now I can pair them up, 5, 6, and 7. So I still have room in that shell for 1 more electron right there. But I'm only allowed to draw 17 electrons, and if you count all my green dots, there are 17 green dots. I'm not allowed to draw any more. So that's my final Bohr-Rutherford diagram for chlorine. For an atom to be stable, it says in your notes, its outer shell must be full or completely empty. Okay, so I want you to remember that. So right now, chlorine's outer shell, its valence shell, is not full. So it actually wants to eventually grab an extra electron from somewhere. But we don't know where that's coming from yet. So that's going to be on a different day. We're going to talk about that topic. So for now, your learning goal, you should be able to find me the number of protons, neutrons, and electrons, and draw your Bohr-Rutherford diagram based on these rules. If I start a blank page now, it says to try this at home. I want you to draw the Bohr-Rutherford diagram for sodium and for oxygen. So I'm going to put these 2 answers on this video. What I'd like you to do right now is actually pause the video. When you have the answers, start playing it again and see if you actually get the right answer. So pause it now, and let's go through the answers for sodium and oxygen. So for sodium, again, if you guys look at your periodic table and your standard atomic notation for sodium, you'll see that the standard atomic notation looks like this. So it gives you your atomic mass, your atomic number, and the symbol. So from that, we have to figure out how many protons, how many electrons, and how many neutrons there are. Oops, I'll use a capital N for neutrons. Okay, once I figure that out, then I can follow my rules and draw my Bohr-Rutherford diagram. So we know the number of protons always equals the atomic number, which is the smaller one. So there are 11 protons. And my protons and electrons always have to be equal. So I know there are 11 electrons. And then to find my number of neutrons, I take the mass number minus the atomic number. So that gives me 12 neutrons. Now I know my number of protons, neutrons, and electrons. I can actually draw my Bohr-Rutherford diagram. So again, let's start. A circle in the middle, and your protons and neutrons go in the middle. So I write 11 protons and 12 neutrons. Okay, that's my nucleus. Now I just have to draw in my 11 electrons, but I have to put them in shells in and around the nucleus. So here's my first shell. I have to fill that one up first, but I know because of the 2-8-8 rule, I can only have 2 electrons in there. So there's the first 2. Now that shell is full, now I can go and start to fill up the second shell. Okay, so there's my second shell. I can put in a maximum of 8. Okay, so I've got 1, 2, 3, 4, 5, 6, 7, and 8. All right, now if I count all my green dots, I've actually drawn 10 electrons. But if I look back up here, I know I have to draw 11, so I need to draw 1 more. Where do I put that? Where does it go? I know I can only have 2 electrons in the first shell and 8 electrons in the second shell, and I've already drawn those, so those shells are full. So that last electron actually ends up in the 3rd shell, or the 3rd energy level. So I draw my 1 little electron all by itself up there, and I am done. That's my Bohr-Rutherford diagram for sodium. Okay, let's follow the same steps again and do oxygen. So if you look on your periodic table, your standard atomic notation for oxygen looks like this: 16, 8, and an O. That's the symbol for oxygen. So let's do the same thing again. How many protons, how many electrons, and how many neutrons? You should be writing this down every single time I ask you to draw a Bohr-Rutherford diagram. So my number of protons in oxygen is the same as the atomic number. That's the smaller of the 2 numbers, so that's 8. 8 protons. My protons and electrons are always equal, so I know I have 8 electrons. And then my number of neutrons is the mass minus the atomic number, so that's 16 minus 8, 8 neutrons. So now that I have that information, I can draw my Bohr-Rutherford diagram. So again, we start with a circle in the middle to represent the nucleus. We put our protons and neutrons in there. In this case, they're both the same. So you write 8 protons, 8p, and 8n for 8 neutrons. Now I have to draw in 8 electrons, but I have to put them in shells. So I have to fill the first shell before I can fill any others. So I put the first 2 electrons in that first shell. There's 2 electrons, 1, 2. I still have 6 more to draw though, remember, because I actually have 8 electrons. So those other 6 electrons, where do they go? They go in the second shell. So we have 6 more to draw. 1, 2, 3, 4, and then top 5 and 6. If you look at both of these cases, the valence shell, that's the outermost shell. So in oxygen, it's the second shell, and sodium, it's the third shell. These are your valence shells. Okay? And in both of these cases, they're not full. And I said in your notes that for an atom to be stable, that shell has to be full. So these atoms are actually not stable. We're going to talk about what that means and how we can fill up or empty out these valence shells on another day. So for now, all I want you to be able to do is be able to draw these Bohr-Rutherford diagrams and just recognize that the valence shells are not full. So that's it for today. We're going to keep practicing this in class, and then we'll learn some more about filling up these valence shells. You can